Hi, welcome to Newton's Law of Universal Gravitation. So here are some questions. If the planets are orbiting the sun, what force is holding them together? What force keeps the moon in its orbit? And could the force of gravity be universal? Well, if the apple was attracted to the earth, are all objects in the universe attracted to each other in the same way? That was Newton's question. The answer is yes. Every object with mass attracts every other object with mass. Newton realized that the force of attraction between two massive objects does two things. It increases as the mass of the objects increase, and it decreases as the distance between the objects increases. So that means that force is directly related to mass, but it is indirectly related to distance. So because we're talking about incredibly big and incredibly small numbers, we need to talk about scientific notation. Scientific notation is just a short way of writing really, really big. Notice that is a 5 with 12 zeros behind it. And we would write it as 5 times 10 to the 12th. Some calculators would even say e to the 12th. And e just stands for times 10. Or really, really small numbers. That's a decimal point, 10 zeros and a 3. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros and a 3. So this is written as 3 times 10 to the negative 11th. Now, the decimal point, which is right here on a small number and at the very end on a big number, the decimal point is literally what's being moved when you multiply by 10. This is times 10 to the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11 to get it behind the 3. If you're moving it to the left, it's going to become a positive number. If you're moving it to the right, it's going to become a negative number. So that's scientific notation. You will have to do calculations with it, but if you understand that it is just moving the decimal place, it's a lot easier. You're going to need to find the to the button on your calculator, or you're going to need to watch how I use Desmos. Desmos will be your friend for this. So on a formula sheet, you need the law of universal gravitation. It is F, big F, is equal to big G, M1, M2, those are just the masses, divided by R squared. Now, big G is the gravitational constant, and it's actually a number like 9.8. But 9.8 is here on Earth. This is the universal gravitational constant. It's the constant of the universe. And it is 6.67 times 10 to the negative 11th Newton meters squared over kilograms squared. M1 and M2 are the masses of your two bodies, and those are going to be in kilograms. R is the distance between them in meters. And there's a video on my YouTube channel that will help explain this more. And therefore, F is the force in newtons. Now, we don't always just have to find force. Sometimes, right, we find force. Sometimes we have to find the distance between them. And that's going to be that equation. Now, on all of your assignments and even on the test and the quiz, I'm going to give you the equation. You just have to know how to use it. So if you're trying to find distance, you're going to use this equation. R is the square root of big G, M1, M2 divided by F. Sometimes you have to find mass when they're not the same, and that's going to be M1 or M2, whichever, doesn't really matter, is equal to FR squared over big GM. And then finally, sometimes you have to find the mass when the masses are matching. That would be the square root of FR squared divided by big G. So The law of universal gravitation is known as an inverse square law. If the distance doubles, the force drops to a fourth because 2 squared is 4. If the distance triples, the force is cut by a ninth. Okay. If the distance is multiplied by 10, we divide the force by 100. It's an inverse square law. Gravitational force exerted by a uniform sphere on a particle outside the sphere is the same as the force exerted by the entire mass of the sphere were concentrated at its center. So the force that mass 1 exerts on mass 2 is equal and opposite to the force that mass 2 exerts on mass 1. They literally are have the exact same force against each other. The forces form a Newton's third law action-reaction pair. Any two objects attract each other with gravitational force proportional to the product of their masses and inversely proportional to the square of the distance between them. It is an inverse square law. The force of attraction in the direction of the force has to line up with the centers of the mass. Okay, and you're going to be using a simulation today. Newton discovered that gravity is universal. Everything pulls on everything else. This is the video explanation you're going to be looking at on my YouTube channel. This is the simulation that we're going to be playing with to do our assignment today, and here's how you use it. So when you open the simulation up, I want you to notice that you can move the ruler. These are 4 meters apart. You're given the force up here twice because, again, it is not doubled. They literally are just telling you that the force on one is the same as the force on the other. You can adjust the mass of the object, and that does affect the force. Okay. So let's play with a particular problem. Let's say you have these two masses of 390 and 650. What is the force if they're 7 meters apart? Well, if you set mass 1 at 0, mass 2 can be 7 meters apart. The simulation literally tells you the answer. 3.45 times 10 to the -7th. But what if you know the force, but you don't know the mass? Okay. You can literally adjust everything on here so that you can do the assignment today. So let's look at an example that doesn't involve the simulation. Jimmy is attracted to Betty. Those are names of moons, by the way. Jimmy's mass is 90 kilograms and Betty's mass is 57 kilograms. If Jim is standing 10 meters away from Betty, what is the gravitational force between them? Well, Fg is equal to big G, m1, m2 divided by r squared. So we would need to do that calculation. Let's flip over to Desmos and let me show you. In Desmos, you have this beautiful scientific calculator. Realize that in Desmos, you want a fraction, which is on the far right. You need big G. Big G is 6.67 times 10, and your to the button is this A to the B button over here, to the -11th. But then you do have to come down out of that, right? Be sure that you come down out of the exponent. Times Jim's mass, 90, times Betty's mass of 57, times Jim's mass of 90 times Betty's mass of 57, divided by the distance between them squared. Okay, and you get 3.42 times 10 to the -9th. This tool in Desmos is going to be very, very helpful in finding these answers. Good luck. Thanks for watching.